Here I have a problem that says estimate the area between each curve and the x-axis over the given interval using the specified number of trapezoids. Give your answer to four significant figures. So our function is the square root of x, and we're looking on an interval from 0 to 4 with n is equal to 5. So just a general idea of what we're trying to find. If we function f of x is equal to square root of x, it has a shape that looks like this. And on the interval from 0 to 4, let's say that this is 4 here, we are trying to find the area under this curve. So this area right here. We're trying to estimate that curve by using 5 trapezoids. And one method of doing that directly would just be to set up the integral from 0 to 4 of the square root of x dx. So if we find this, the integral from 0 to 4 of square root of x dx, that would give us the exact area. But they're not wanting us to find the exact area. The question is asking for us to estimate it. So to estimate it using trapezoids, we need to use the trapezoid rule. So the trapezoid rule says that if we have the integral from a to b of f of x dx, that is equal to the change in x over 2 times f of x0 plus 2f of x1 plus 2 f of x2 plus dot dot dot, so this is just continuing from the previous line, 2 f of x in minus 1 plus f of x in, and then we just close the bracket. So this is where delta x is equal to b minus a over n, and we divide our a to b into n subintervals. So the first subinterval would start with x sub 0. So if we start with x sub 0, we would end with x sub n. That's the general idea of how the subscripts work. So in order to plug this into our function, we need to identify what our a and our b and our x sub 0 and all of those things are. So to find our delta x, we can plug in our b minus a, which our b and our a in this case is 4 minus 0 over n, which is our number of subintervals, and they gave us in the problem that n is equal to 5. So our delta, whoops, I left off my x, our delta x is equal to 4 minus 0 over 5, which would be 4 over 5. Now, that gives us our delta x, and our x sub 0, we need to identify like what all of our x's are. So let's first draw this out. We're looking for, let me just copy this over here. This is the integral that we're trying to find. We're looking for the integral from 0 to 4 of the square root of x dx, and that's equal to delta x over 2. So we know our delta x is 4 over 5. And we can put that over 2 times the function where x is equal to 0. So x of 0, we know that we're starting at 0. So this would be f of 0 plus 2 times f of 1. So f of x1. So f of x1, if our delta x is 4 over 5, that means that we're adding 4 over 5 each time until we get to our x sub n. So if we add 4 over 5 to 0, 0 plus 4 over 5 is 4 over 5. And then we can add plus 2 times f of, now we have our x sub 2, so we need to take our x sub 1 and add another 4 over 5. So if we take 4 over 5 and add 4 over 5, that would be 8 over 5. And then we add another plus 2 times, so this was x sub 0, this was x sub 1, this was x sub 2. We need to get all the way to x sub 5. So here we have x sub 3, which is f of 8 over 5 plus 4 over 5 would be 12 over 5. So that would be my next x. And then plus, so this is x sub 0, x sub 1, x sub 2, x sub 3. My next one is x sub 4, which still needs to be multiplied by 2. My last one doesn't need to be multiplied by 2. So this would be 2 times f of, we need to take 12 over 5 and add 4 over 5, which would be 16 over 5. And then add our last f of n, so this is x sub 0, x sub 1, x sub 2, x sub 3, x sub 4, f of x sub n, which would be f of, it should be, we know that our last term is 4, but let's check and see. If we add 4 over 5 to 16 over 5, that makes 20 over 5, which 20 over 5 does simplify to 4, so that verifies that our end point would be 4, so that's good. So now from here we need to evaluate what all of these things are. Let me give myself a little bit more room. So first of all, we can take our 4 over 5 divided by 2, flip the bottom fraction and multiply to make that 4 over 10 times f sub 0 would be plugging in 0 into my square root. So this would be the square root of 0, which is 0, plus 2 times, we can write that as the square root of 4 over 5, and then plus 2 times the square root of 8 over 5, plus 2 times the square root of 12 over 5, plus 2 times the square root of 16 over 5, and then plus, the last one would be not times 2, just the square root of 4. And that finishes it off. So then, to evaluate this, let me grab my calculator, because we're supposed to answer the problem in a decimal solution to 4 significant figures. So if I plug this into my calculator, I get, well, first of all, 4 over 10, I can simplify that to 2 over 5 times, I don't have to put in 0, I can just do 2 times the square root of 4 over 5 plus 2 times the square root of 8 over 5 plus 2 times the square root of 12 over 5 plus 2 times the square root of 16 over 5, and then plus the square root of 4 is just 2, so I can put that in as 2 at the end. And what that gives me just making sure my parentheses are put in correctly into my calculator. I get that to be 12.99472 times my 2/5. I'll just keep that number in my calculator, multiply by 2, divide by 5, and that gives me 5.197909. And the question asks for me to give my answer to 4 significant figures. So 4 significant figures would be 1, 2, 3, 4. I need to round to my 7, which number after 7 is bigger than 5, so I add 1 to my 7 to get 5.198, which would be my answer. So this was using the trapezoid rule, using a formula kind of a strategy, and I hope this was helpful for you. If you have any questions, please feel free to leave them in the chat box, and share this with anyone who you think might find it helpful. Thanks.